the sum of a GP. When we say the sum is still the same thing as series. So the series of a GP is the sum of each term of that GP. For example, this is a GP. 1, 2, 4, 8, 16 is a GP for the common ratio 2. This is a sequence, that is geometric sequence. Then the series of this sequence is the sum of each term of that sequence, and it is called series. 1 plus 2 plus 4 plus 8 plus 16. Series has to do with sum of terms. Now, if you are asked to find S1, S1 is the same thing as 1. S2, that is sum of the first and second term, 1 plus 2. S3 means sum of the first, second, and third term, which is 1 plus 2 plus 4, and so on till you get to Sn, which is the same thing as saying 1 plus 2 plus 4 plus until you get to the last term. Now that we know that sum of means series, now let AR, that's the first term, second term, third term, AR squared, till you get to ARN minus 2 and also ARN minus 1. This is a sequence. What if you are to determine the series of this sequence, which means the sum of each term of this sequence? We can say, you agree with me that Sn is the same thing as A plus AR plus AR squared plus ARN minus 2 plus AR to the power of n minus 1. This is the series of the sequence. Also, if I am to call this equation 1, I want to derive another equation which I will be multiplying Sn by R. So if you are to multiply Sn by R, and this is my Sn, it means that the first term here will be multiplied by R, which is going to be AR. The next one by R will be AR squared. This multiplied by R will give me AR to the power of 3 plus, when you multiply this by R, since you multiply this by R, you get the next term. So in this case, it means when you multiply this by R, you get A to the power of R minus 1. And when you also multiply this by R, you get A to the power of AR to the power of n. Call this equation 2. Now, we are to carry out a simple operation. Subtract equation 2 from equation 1. If you are to subtract equation 2 from 1, it means you are to subtract Rsn from Xn. And what will the results look like? It means A minus AR, AR minus, let's write it out. A minus AR, then plus this AR now, minus AR squared, plus this AR squared, minus AR3, since we are subtracting. Now, when you look at the pattern in which this follows, we are always having like terms. This and this will knock out. A minus AR plus AR gives 0. Also this. When you continue this way, you realize that every single term will be knocked out except the first term and this term, which also means that ARN, so you will get to a stage whereby you have AR raised to power n minus 1 then minus AR raised to power n. And in this case, you will have this to subtract this. That is, there will be something here minus AR raised to power n minus 1 plus this. And these two will knock each other out. Then you will be left with S into n minus R Sn, which will give us A. Will be left with this and this. So A minus AR raised to power n. So we have A minus A raised to power r, AR raised to power n. Now, Sn is common on the left hand side. So it means we can factor Sn out and we have 1 minus r. Also on the right hand side, A is common, which means you can factor A out and have 1 minus r raised to power n. So if you have to divide both sides by 1 minus r, since our focus is to determine Sn, then our result will be A into 1 minus r raised to power n over 1 minus r. Now this formula has another version. That is, if from this part we are subtracted it the other way around. That is, we had said subtract 1 from 2. If we had done the subtraction of 1 from 2, our result would have been something like this. Sn would have been A into r raised to power n minus 1 over r minus 1. You can use any of those two in any given question. But for computational stability, that is to avoid unnecessary negative sign, you can pick this one when the value of r is less than 1. That is, we have something like fraction, something like fraction, a fractional number that is below 1, something like 1 over 2. You can make use of this formula. Then this, if you have the value of r to be greater than 1, you can go for this, just for computational stability. Now, this formula has a third version. That is, if we have the infinite terms, that is, you are asked to find the sum to infinity. That is, you don't know the number of terms that the GP has, but you are asked to find the series. How do you calculate that? In that case, strictly do not use this second one. It is strictly the first one. Then you will now determine the limit, that is, as n tends to infinity. Then you have something like this, A over 1 minus r. So this is the third version of the formula. So if you are to calculate the sum to infinity, you make use of this. But you can use either of these two to calculate. So let's solve a problem under this. Given the GP 1555 over 3, that is, this is the first term, second term, third term, then you are asked to determine the sum of the 12th term of the GP. The first term of that GP is A, and that's 15. The common ratio, which is R, can be determined by saying a term divided by a term before it, and this gives us 1 over 3. For a proper confirmation, you can also carry it out by saying 5 over 3 divided by a term before it, which is 5. And that gives us 5 over 3 times 1 over 5, which is still the same thing as 1 over 3. Now, you agree with me that R is the same thing as 1 over 3. So, since R is a number that is less than 1, which of this formula do you think we should use? This. Good. So let's go back to the question. Our Sn is the same thing as A into 1 minus r raised to power n over 1 minus r. Now, in this case, what is our n? Our n is 12 because we are asked to find the sum of the 12th term of the GP. So S12 gives us A is 15 into 1 minus the value of r is 1 over 3 to the power of n, which is 12. everything all over 1 minus 1 over 3. Now, 3 to the power of 12 will give us 3 to the power of 6 into 2, which is the same thing as 729 to the power of 2. And if you do that further, you have 531441. All right, so that is 3 to the power of 12. So then we have x12 to be 45 over 2 times 1 minus 1 over 531441. If you do a further simplification, you have 45 over 2 multiplied by 531441 over 531440. And if you further simplify, our S12 will be 13286 over 59049, which is approximately 22.49996. You can try this on your own. Very simple. If this video is helpful, subscribe to this channel.